Every architecture in this lineage was chasing one problem: how to handle a sequence with context, feed forward nets, then RNNs, then LSTMs, then sequence to sequence, then attention, and finally the transformer. Each one fixed the failure of the one before it until attention fixed them all. The 2017 paper put it bluntly: attention is all you need. Start at the beginning. A feed forward net computes H equals sigma of Wx plus B. Input to hidden to output, one direction, fixed size, no memory of order. But language isn't fixed size and order is everything. Feed words in as a bag, and dog bites man becomes identical to man bites dog. The meaning is gone. We need something that respects sequence. The recurrent net added memory. It feeds its hidden state forward, ht equals tanch of wxxt plus wh ht minus 1. A running summary that grows token by token and works for any length. But it has three fatal flaws. Gradients vanish as they multiply back through time, or they explode, and the entire history is crammed into one fixed vector. So in practice, it only remembers about 5 to 10 tokens. The LSTM fixed the memory with gates, a forget gate, an input gate and output gate, deciding what to keep and what to drop. The key is the cell state. It's updated by addition, FTI times the old cell, plus IT times the new. Because it's additive, gradients flow across many steps without being ground down, a memory highway. The GRU does the same with fewer gates, but both are still sequential, unparallelizable, and they fade past a few hundred tokens. To translate, we used sequence to sequence. An encoder squeezes the whole input into one fixed vector, and a decoder unpacks it. But that single vector is a choke point. On long text, detail gets crushed. Badenow's fix in 2014 was attention. Let the decoder look at every encoder state and take a custom weighted blend each step. A query, keys, values, softmax weights a context vector. That exact skeleton becomes self-attention. And then the leap. If attention already handles long-range dependencies, why keep the slow recurrence at all? Drop the LSTMs entirely, keep only attention, and parallelize across the whole sequence at once. That's the transformer. All words attend simultaneously. It runs fully parallel on GPUs. It keeps order through positional encoding, and it scales beautifully with depth and data. First, some housekeeping. Text is chopped into tokens. Word level explodes the vocabulary. Character level makes sequences too long. Subword, byte pair encoding strikes the balance, keeping common words whole and splitting rare ones into reusable pieces. Each token ID then looks up a row in an embedding matrix V by D. Those IDs are arbitrary labels, but the embeddings place similar meanings near each other in space. That is what the transformer actually operates on. Now the heart, self-attention. Take I like this girl. To know what like means, the token has to look at the words around it. So every token takes on three roles. A query, what am I looking for? A key, what do I offer to others? And a value, the content I actually contribute. Each is just a learned projection of the embedding. Q equals XWQ, K equals XWK, V equals XWV. Here is the formula that runs the world. Attention equals softmax of QK transpose over root dk times V, step by step. Q times K transpose gives an n by n grid. How much should each token attend to each other token? Divide by root dk, or in high dimensions, the dot products blow up and softmax flatlines. Softmax turns each row into a clean probability distribution, and multiplying by V gives the weighted blend of values. That's it. One attention is not enough. Run it h times in parallel, each head with its own Q, K, and V projections. Then concatenate the results and mix them with WO. The original used D of 512 split into 8 heads of 64 dimensions each. Why 8? Too few and each head is overloaded too many, and each slice is too small to mean anything. And in practice, different heads specialize. Some track grammar, some meaning, some position. Two variations. In the decoder, we mask a token must not peek at the future, or it would just cheat during training and fail at inference. So we set all future positions to negative infinity before the softmax. They become 0. Each token sees only itself and the past, and cross-attention bridges decoder and encoder. The query comes from the decoder, the keys and values from the encoder. So generating French chats, it attends to English cats. Decoder-only models like GPT skip cross-attention entirely. After attention mixes information between tokens, each token is processed on its own by a feed-forward network. Max of 0 and xw1 plus b1 times w2. It expands the dimension 4 times, 512 to 2048, applies a ReLU, then contracts back. The ReLU is essential. Without it, stacked layers collapse to one linear map, and this FFN holds most of the transformer's parameters, about 4 million a layer versus 1 for attention, which is exactly why mixture of experts targets it. Two pieces hold deep transformers together. Residual connections, output equals LayerNorm of x plus sublayer of x. That skip path is a gradient highway, and it lets each layer learn only what to add. Without it, a 96-layer model simply won't train. And layer normalization, gamma times x minus mu over root sigma squared plus beta, normalizes across a single token's features, not the batch, so it works at inference, one token at a time. Modern models swap in RMSNorm, which is faster, and apply the norm before the sublayer for stability. There's a problem. Attention sees an unordered set. I like cats and cats like I look the same, so we inject position. The original used sinusoids PE of pos equals the sine of pos over 10,000 to the 2i over d, giving every position a unique fingerprint of sine waves, from which relative distance can be read. Modern models do better. Rope rotates the query and key by their position, so the dot product keeps only the relative distance, and it extrapolates far past the training length. ALiBi just subtracts a slope times the distance from the scores. Dead simple, and it stretches from 2000 to 16,000 tokens. Assemble it. One layer, self-attention, add a norm, feed forward, add a norm, and crucially the shape never changes, so you stack it to any depth. From that one block come 3 architectures: encoder only like BERT, bidirectional, trained by masking 15% of tokens and predicting them, great for understanding and embeddings; decoder only like GPT, Llama and Claude, causal, trained purely on next token prediction, and predicting the next token over a vast corpus forces it to learn language, facts and reasoning; and encoder-decoder like T5 for when input and output are structurally distinct. The modern block has evolved. SwiGLU replaces the ReLU feed forward with a gated activation, where one projection modulates another, and it beats ReLU at scale. Grouped query attention shares keys and values across query heads, shrinking the cache. FlashAttention computes the exact same math, but in a GPU memory-aware way, never building the full n by n matrix. And because full attention is order n squared, models go sparse. A sliding window where each token sees only w tokens back, order n times w. The trick is depth, stack L layers, and the effective context becomes L times w. 32 layers at a 4000 window reaches 130,000 tokens. Finally, running it. Generation has 2 phases. Prefill processes the whole prompt at once, in parallel, compute bound, and it sets your time to first token. Decode then generates one token at a time, sequentially, memory bound, and it sets your tokens per second. The key optimization is the KV cache, store each token's key and value once and reuse them, turning decode from order n squared into order n. But that cache explodes. A 70 billion model at 100,000 context is about 32 gigabytes, the real production bottleneck. Zoom all the way out, and the whole machine is this: tokens to IDs, embeddings plus position, a stack of decoder layers, a projection to the vocabulary, a softmax to the next token, trained in parallel with a causal mask, generating one token at a time. That is the transformer.